All right, welcome to the Explainer. Today we're talking about Kotlin. It's this super modern programming language that's pretty much everywhere. It's probably running on the phone in your pocket and powering a lot of the apps you use every day. So we're going to dive in and see how you can use it to talk to a computer. And do it in a way that's not just powerful, but also really safe and honestly pretty slick.
I mean, at the end of the day, that's what programming's all about, right? It's just telling a computer exactly what to do, step by step. But the real trick is, how do you organize all those instructions so the computer actually gets it and does something useful? Well, that's exactly why languages like Kotlin exist. Okay, so here's the plan. We're going to start with the absolute basics, the building blocks, which are functions. Then, we'll get into how to store information using variables and types. After that, we'll look at how to make your code smart with conditionals, and then how to organize everything with classes. And we'll wrap up with this really cool feature called nullability. It's kind of Kotlin's secret weapon for writing code that doesn't crash. Sound good? Let's jump in.
All right, first things first, functions. The best way to think about a function is like a recipe. You know, you write down the steps for making your favorite cookies once, give the recipe a name, and then you can just grab that recipe anytime you want to make them. You don't have to figure it all out from scratch every single time. That's a function. It's a reusable command.
So let's take a look at what a function actually looks like in Kotlin. See that little word fun at the beginning? That's just you telling Kotlin, hey, a function is coming. Then you give it a name that makes sense, like birthday greeting. The stuff in the parentheses, those are the parameters, the ingredients your recipe needs. In this case, it needs a name and an age. And then inside those curly braces, that's the body. Those are your instructions, the actual steps of the recipe.
Okay, so our functions are like recipes. They know the steps. But a recipe is pretty useless without ingredients, right? It needs flour, sugar, data. And in code, we store that data in variables. Think of them like label jars in your pantry for all your different ingredients.
Now, Kotlin has this really simple but super important rule. You've got two kinds of containers. If you have some info that's never ever going to change, like say your birth date, you put it in a val. Think of it as value. It's constant. But if you've got something that can change, like your score in a video game, you use a var for variable. Just making that little choice makes it way clearer what your code is supposed to be doing.
And just like you wouldn't store soup in a paper bag, these variable containers are designed for specific kinds of data. We call these data types. So, if you're dealing with text, like hello world, you use a string. For whole numbers like 10 or -50, you use an int, short for integer. If you need decimal points, like for pi, 3.14, that's a double. And for simple yes or no situations, you've got the Boolean, which can only ever be true or false.
Okay, we've got our instructions, our functions, and we've got our data, our variables. But this is where things get really interesting. The real magic happens when your code can start to think for itself, when it can make choices. Let's see how we get our programs to react to the world around them, right?
I mean, you don't want your program to just do the same thing over and over no matter what. You want it to be smart. Think about it. A self-driving car pulls up to a traffic light. What does it do? Well, it depends, doesn't it? It all depends on the color of that light. So the old school way to handle this, the way you'll see in a lot of languages, is with an if-else structure. It's pretty logical. The code asks, is the light red? If the answer is yes, it runs the stop command, and then it's done with the whole block. But if it's not red, it moves on to the next question. Okay, well, is it yellow? This totally works, but you can imagine, if you have a bunch of different options, these if-else chains can get really long and kind of hard to read.
And this right here is a perfect example of what makes Kotlin so great. It takes these concepts we already know and just makes them better. It gives us a cleaner, more elegant way of doing things.
Check this out. This is Kotlin's when statement. Instead of a long chain of ifs and elses, you just say, when the traffic light color is, and then you just list out the possibilities. When it's red, do this. When it's yellow, do that. It's doing the exact same job as that messy if-else block, but look how much cleaner and easier it is to understand at a glance. This is a real game changer for readability.
All right, so up to this point, our code has been kind of like a pile of loose Lego bricks. We have our function bricks and our variable bricks. That's fine for small projects. But what happens when you want to build a giant, complex program? You need a better way to organize things.
You need blueprints, and in programming, our blueprints are called classes.
And this is such a critical idea to get right. A class is not the thing. It's the plan for the thing. Think about a blueprint for a house. The blueprint specifies all the details, the properties, like how many bedrooms it has, and it also defines the behaviors, like how the doors open. The blueprint itself isn't a house you can live in, but you can use that one blueprint to build a whole neighborhood of actual houses. Each one of those houses is an object.
And this blueprint idea gets even more powerful with inheritance. You can have a very general blueprint, say for a smart device. It defines that all smart devices have a name and can turn on and off. Then you can create more specific blueprints, like one for a smart TV. It can inherit all the basic stuff from the general blueprint and then just add its own special features, like changing channels. It's an incredibly smart way to reuse code.
So, let's tie this all together. Remember that birthday greeting function from the very beginning? Instead of just having it float around by itself, we can create a person class. This class acts as a container. It holds the data about a person, their name and age, and it also holds the behaviors related to a person, like our greeting function. See how that works? Everything that has to do with a person is now organized neatly in one logical place.
Okay, last but definitely not least, we're going to tackle what is, no joke, one of the biggest, most annoying problems in the entire history of software. It's this. What happens when a variable is supposed to have data, but it's empty? It's null. In most languages, your app just crashes. Boom. Game over. But Kotlin? Well, Kotlin has a brilliant solution for this.
Okay, look at these two examples. On the left, you see those two exclamation points? That's you shouting at the computer, "Trust me, I promise there's a value here. Just do the thing." But if you're wrong, your app dies. It's a huge gamble. Now, look at the right. That's the Kotlin way. That little question mark is a safe call. It's like politely asking, "Hey, variable, if you happen to have a value, could you please do this? If not, no worries, just skip it." No drama, no shouting, and most importantly, no crash.
And Kotlin gives you even more tools. You can combine that safe call with what's playfully called the Elvis operator. If you tilt your head and look at the colon and the question mark, it kind of looks like his hair and eyes. Anyway, what it does is awesome. The example here says, try to get the nullable name. But if it's not there, if it's null, then just use the name guessed instead. It lets you provide a fallback, a default value, so your program can always move forward gracefully.
And really, this is the whole point. This whole nullability thing isn't just a nifty feature, it's at the very heart of Kotlin's design. The person who invented null in programming later called it his billion-dollar mistake because of all the crashes and bugs it has caused over the decades. Kotlin was designed specifically to fix that mistake. It forces you to think about what should happen when data is missing. Because of that, you build apps that are just fundamentally safer.
So there you have it. We've gone from the simplest instructions to storing data to making choices, all the way to building these complex, organized blueprints with classes. We've seen firsthand how Kotlin is all about making your code clear, well-organized, and incredibly safe. You've got the building blocks now. The foundation is set. So the only real question left is, what are you going to build first?